the next thing I'd like to talk about, since we've really been spending a lot of lecture time discussing input streams and output streams, and one of the best things about the concept of streams is we can be agnostic. We could be unknowing as to where the data is coming in from the stream or where it's going out, right? So it allows us just to focus in on this concept of input and output into our application without having to be too concerned about what that input is. That is like, what is the inputting entity or what is the outputting entity? Now, most common for us is going to be files that represent the data that's being inputted or outputted into our system. It doesn't have to be a file. Like, it's possible it could be some other application, for instance. And that application could either be a local application or it could be a networked application. So it could be through like a socket that we're getting our information in or out. But very commonly, it's a file. So I want to spend just a few moments. I want to spend this video talking a little bit about files and just ensure that everyone is feeling comfortable with the concept of a file, at least as it relates to Java. So a quick overview here is we're going to have an introduction to the file class in Java. We'll look at the file class declaration, its constructors, its methods, and some example code. So here, in terms of our introduction, so far we've used variables and arrays to store data inside of Java programs. And we've looked at the output and input streams. We have created files with that, but we haven't directly looked at the file class. And so the file class allows us, even though we've used it to create files, we haven't really examined what it provides to us, but it was created to alleviate this problem of having to do in-memory storage of data, right? Because the problems with just storing variables and arrays is that, well, you don't have any persistence, right? The data stored in your program is lost when the program is terminated. So that means storage is only temporary if the only way you're storing it is in variables and arrays. And another issue that you have just doing in-memory storage is that, well, for large volumes of data, something that might be like millions of elements, well, that could be difficult to handle using just variables and arrays, right? You might not have enough memory to hold that amount of data. And so files help overcome those problems. We can use a secondary storage device, usually a hard drive, to store large volumes of data. And when we store our data inside of into a file, it's persistent. It lasts even after our application is not running any longer. So what is file in Java in particular? So we can say that a file is a collection of related records that's located in a specific area of the disk that stores the user and system data. And so a record typically consists of many fields or values. So a field contains a group of Unicode characters composed of 2 bytes. Each byte contains 8 binary digits of ones or zeros. So effectively, every file is writing characters. Now, if a binary file, if we try to open it up, it'll still try to print characters. It's just the characters aren't human readable. They're not designed to be read. Now, the characters that are designed to be read are the ones that are like our text files. So in a system, files are organized using directories. A directory in Java is a file within a file system that contains several files and other directories. A file system is a hierarchy of files and directories, starting from a root directory. The root directory is your topmost directory in the file system. So the concept of root comes from the idea of a tree. So there's one direction you travel in a tree, right, from the root node. So that would be inside of my Apple system, that would be starting with a slash. Inside of Windows system would be your C:/, right? That's your root. And then all of your directories are then contained in there. And then you get subdirectories and subdirectories and whatnot. So in Java, files are used by several applications for usually storing and retrieving data. So whenever we're talking about storing or retrieving data using files, this is what's called file processing. So Java supports both the input and output of data through files, as we've already seen. So again, the java.io package provides a class known as the file class that provides some methods to know the properties of files or directories. So with the file class, we could create a file, we can open a file, we can delete a file, we can close a file, we can get the file's name, we can get the size of the file, we can check if the file exists or not, we could rename the file, and we can test whether the file is writable or readable. So now one big thing that you can't do with the file class, though, is read and write, right? You have to read or write through streams, because again, Java wants to be agnostic as to what the source destination is, how things are inputted and outputted from our application. So we can create file objects, right? And we can do all these cool methods with files. We just can't read and write to them directly. We'll always use a stream for that, like either an input stream, an output stream, or a writer or reader instance. So looking at the class declaration, our file class in Java is an abstract representation of a file or directory path name. So it extends the object class and implements serializable and comparable interfaces. So the general syntax to declare a file class, if we were to build this ourselves, would be public class file. It's a concrete class. It extends object, and it's going to implement these two interfaces. So it gains membership into it. And so the file class was added in Java all the way in version 1. And again, it's part of the IO package. So some constructors for file are as follows. We can go ahead and pass a string, which is the path name of our file. So that'll construct a file object with a specified path name. And so the path name may either be a file or directory, and it converts the given path name string into that abstract path name object. Oops. We can go ahead and pass in as a string just the directory path. And then as a second parameter, we can pass in the file name. So that allows us to distinguish the path of where the file is that we want to create the file instance of from the file name itself. I can also invoke the constructor that passes in as a file object, the directory object effectively. So we can create a file that's just a directory, and we can pass it in as a file instance as the first parameter. And then as the second parameter, we can pass in just a string of file. Or the last constructor I have is I can pass in a URI object to create a file. That's you could think of that as a internet object or a network object of where a file might be located online and not on your local machine. So that could be like a HTTP address, for instance. So some additional notes about the file constructors. So a path is a hierarchy of directories that locate a file or directory. So it's the path from the root directory or from our present location to where that file exists at. A path name is a string representation of the path in which a platform-dependent separator character. And so for my system, I use slashes. Now, depending on whether you're on a Windows machine or whether you're on a POSIX compliant machine, is going to depend on whether you use a forward or backslash between your directories. A file name is a unique string of characters that locate a file on disk, and it may consist of two parts: the primary name and then an optional name, and then after that you'd have an extension. Typically your extensions are like 3 letters long. So usually it's like TXT for text or DAT for data. Now you don't have to have an extension. You could technically write a file without an extension. You're just not associating that file with any kind of editor then. So certain editors will look at the extension and your OS will determine how to open it up based off the extension. Now, if it's a custom file for just your application, and if you don't specify an extension, that's fine. Like you can do that. So for instance, salary could be a fine name for a file without giving any extension. And then your application would just open it up as such. So the Java file class does not contain any methods for reading and writing data. We've already covered that. Like that's what streams are for, or input and output streams. And then we must know the purpose of using a file. For example, we should know whether the file is built to be read only, whether it's designed just for writing, or whether we want to do both reading and writing to a file. Okay, so if we want to create a file object in Java, an object of a file class signifies the path name of a particular file or directory on the file system. It is initialized as a string that contains either an absolute or relative path. And so I'm sure we've probably covered this. I've been using relative paths. The absolute path starts at the root directory and defines the path from root to the file name. The relative path allows you to define a path from the current directory you're in. And so relative paths can, in order to define a relation of the current path you're in towards the path where the file might be at, we can use either the dot operator to specify our current directory or the double dot alias. Two dots means my parent or my parent of where I'm currently at. So the directory above the one I'm currently in. So if we want to create an object, so the general syntax to create an object file by passing the file name or directory name would look like this. So here, the file name is a string of characters that identify a file on disk. So what it would actually look like would be this: creating a file object. I could create the new file and then pass in a string with the file name. And then I'd create a file object from that. Or I can just go ahead and create a directory object, right? So a directory and a file are essentially the same thing in the OS. It's a file. It's just a directory is a file that contains references to all of the files inside of it, or directory files that are inside of it. So I can just pass in just a directory like this /book and create a file from that. And so that's going to create a file object for the directory /book. I can also create like a binary file if I wanted to, right? So my character files, my binary files are all files. And it just depends on what I'm writing to it, whether it is designed to be a set of characters that are read as characters, or whether it's a set of characters that are encoded as bytes. So the general syntax to create an object of file class by passing the path name would look like this. So before, we're looking at how to pass in strings. But remember, the constructor allows us to also pass in path names as well. So here I can create a string with a path name. Here's the general syntax to create an object of the file class by passing in the path name and the file name. So remember, you have the constructor where you pass in the path name as the first parameter and the file name as the second. So if you don't want to combine the two, this might be useful programmatically, right? Where you might save the path name as a string, and then you might have a for loop that's like generating a set of files. And so here it would be very easy just to go ahead and have that set be some variable that's getting passed in. Okay, so in terms of file methods, the file class in Java provides various useful methods for obtaining the properties of a file or directory and for renaming and deleting those files. The most commonly used ones I'll list, but just again, a note that the file class in Java has a lot of methods that perform a variety of functions, but it doesn't provide any methods for reading and writing. Again, that's what we use the reader and writer classes for. So file methods we should know about. There's an exist method that tests whether the file or directory is represented, that we've created is actually one that exists inside the file system. We can query, can we execute that file? So that lets us know whether it's a runnable file. We can find out if the file is readable. Can we read that? Do we have reading privileges on that file? And we can also ask if is that file something we can write? Do we have writing privileges on that file? We can go ahead and query is absolute. So the method returns true if the file object is created using an absolute path name. In other words, it checks whether the abstract path name is absolute. We can query whether it is a directory. So it's going to return true if the file object represents a directory, false otherwise. We can query, is it a file? So the method returns true if the file object represents an actual file and not a directory, right? So usually when we think of these file objects, they are in one of those two states. Either it's representing a directory, it's representing a file. We can query whether it's hidden or not, is whether it's a hidden file. We can create a new file. So this is basically constructs a new empty file named by the abstract name if and only if a file with this name does not yet exist yet. We can go ahead and invoke delete. And again, it's going to return a Boolean value, whether it was successful or not. We can tell this method deletes the file or directory represented by the file object and returns true successful, false reason couldn't. We can get the absolute file. So this method returns the absolute form of the abstract path name. Get absolute paths. This method will return the absolute path name string of the abstract path name. See, so this returns it back as a file object, or this returns it back as a string object. We can also get the canonical file path represented either as a file or as a string. So this will get canonical file. This will get the path. And then we could also get the free space. So this method returns the number of unallocated bytes in the partition named by that file. So we can see how much space is left to write into that file. We can also get the name of the file, and that returns just the name and not the string. I'm sorry, not the path. We can get just the path of the file, and so that will return the path, the full path. So for instance, here, if say, for instance, this was the path, or this is the file object we created. If we called get path, it would return just myfile.dat. Whereas if we call get path on this file object, the same file object we looked at before, it will give us the entire path to that file, including the file name. And then get parent, if we were to have, say, for instance, this file object here, and we call get parent, it's just going to give us the directories ahead of it. So it won't give us the file name, it will give us the parent directory and all of its parent directories. We can get the total space. So we saw how we can get the free amount of space, what's not used. Get total space will be the entire size of the partition defined by that path name. And then get usable space will return the number of bytes available inside the virtual machine on the partition specified by the abstract path name. We can find out when the file was last modified. Last modified gives us that. Length tells us the length, the size of the file, or 0 if it does not exist. List will return a string array naming the files and directories in a directory that's represented by a file object. So if it's a directory we're looking at, we can list all the files inside that directory, or all, and the directories in there. So it gives us everything. We can also put list files. This will return as a file array all of the directories inside of a file object that's representing a directory. So we can get those back either as a collection of files or as a collection of strings. And so list roots will list the available list system roots and give back a file array of that. So it'll give you the as files, all of your as file instances, all of the root directories. We can also invoke on file make dir. So this creates a directory represented in the file object. It returns true if the directory is created successfully. Make dirs is the same as make dir, except that it creates a directory along with all the parent directories if they don't already exist. So make dir will make a directory, but it will only make it can't make nested directories. Make dirs allows us to make nested directories. So a directory inside of a directory, and both of them don't have to exist at the time that we call that. We can call rename to. So this the rename to. Whoops. let's correct that. The rename to method is used to rename the file or directory represented by the file object to the specified name that's represented inside the destination inside this parameter. And so it returns true if the operation is successful or not. And then to URI, this method will create a file with the URI representation. And then we can set read only. So set read only marks the file so that it's a read only file so that you don't have writing privileges to it. Set executable is a convenient method to set the executable permission for the owner of the file. Then we have set executable as a overloaded method. So here we can set as a Boolean value whether it should be executable or not. And then we can also put who the ownership, whether we want it executable for the owner or whether we want it executable for everybody. We have the ability to make files to be set so it can be read, set readable, and also the option to overload it so that we can have the option to make it set readable only for the owner or for everybody. Because you have different user groups on the OS effectively. And so certain user groups will, like, for instance, an admin can have read privileges and people who are not part of the admin group would not. And then you have set writable, where you can set the file so that it can be written into, and that's overloaded so you control the user group on the OS who can write to it. Okay, let's look at some examples for the file class. So let's check to see if a file exists. So this is going to be our simple code. It's what we're going to expect. Let's actually go to IntelliJ. Yeah, I'm pretty sure. I'm just waiting. Yeah, there we go. Okay, let's close out of this. Nope, don't want that. Let's go here. Let's go to open. Let's go to files. Okay, perfect. So here we're going to go to file tester1. So I'm going to import from java.io the file class. I'm going to create a class so I can create a main method. So file tester1, we're going to create a main method, and I'm going to create two files. Well, two file objects. Not creating files, I'm creating two file objects. The first one's going to be a new file, and it's going to go to the source dot slash. So this is a relative source. So from the current directory, that's lecture 23-files. Inside of the source directory, inside of here, I'm going to then use the name myfile.txt. And if I look, I'll see that I have a file that's called that, myfile.txt. And then I'm also going to do one just at my current directory. So that's inside of lecture 23. I don't have a file of that name. So I'll be able to create file instances, but then I'm going to query file1.exist and file2.exist. Let's actually run this. And what we're going to see here is that since that file actually exists in the file system, the first one, file1, it's going to say true when I invoke that method .exist on the file object. But since this one is a file that does not exist, right? I gave it a path name, and then when it checks the file system, there's not a file there with that name, that's going to say false. So that shows how we can use the file class to check existence of a file in our path in our file system. Okay, let's make another example program here. We're going to create a program where we'll check the existence of a file and display the properties of that file. So let's go to file tester2. Here, I'm going to import file, and I'm also going to import the IO exception. And I'll just have my main method throw the IO exception. And here, what I'm going to do is I'm going to create a file for the pathway that actually exists. So myfile.txt, let's take a look at it. So I don't have anything in it, but it is an existing file. Here, I'll go ahead and check, does it exist? I'll get its name. I'll get the file's length. And actually, let me run this so we can, while I say it, you can actually see. So I'm going to, perfect. Okay, so here I'm going to check to see if it exists. It exists. I'm going to get the file name here with get name. That's going to give me my file.txt. I'm going to get the amount of bytes in the file. There's nothing in it, so it's 0 bytes. I'm going to get the path of the file. That's going to give me the full, that's going to give me the path that I used to define it. So it's going to give me that relative path. Here, I'm going to get the absolute path. Inside the absolute path, notice it's going to actually use that relative pathing as well. So it's going to say lecture 23-files, and then it's using the dot operator, right? It's giving me to illustrate where in the path I'm defined as the current directory. But in the canonical path, it's just going to give me the true root path, right? So /user/ted/idea project/lecture 23-files/source/myfile.txt. Here, I'll get the parent name. So that'll just be the parent of where I'm currently at, of where this file is at. So that's going to be ./source. Here, I'll get the free space that is allowable in this file. So it's a lot. Here, I'll query, is this a file? True. Is it a directory? False. It's not a directory. Is the file hidden? Nope, it's not hidden. Can I read the file? Yes, I can. Can I write the file? Yes, I can write to that file. And then I can check when's the last time that file got updated. July 14th, today. And it even gives me the timestamp on that. Excellent. And that's kind of just a quick overview of the file class and what we can do with it. So